There are a variety of sources of manual and automated data collection in Nevada. They include volunteer stations as well as stations that are run by government agencies. Some of the questions that you might ask yourself about the manual and automated data collection that happens in Nevada include the types of instruments that are part of the volunteer weather data collection network in the state. Another might be where you can get the data that the volunteer network actually collects. Where are the data from the volunteer network? Finally, what's the primary purpose of the RAWS network, or the Remote Automated Weather Station Network, and is the RAWS network useful for snow measurement? Well, there are a number of climate stations in Nevada. You can see the map here on the right-hand side, run by volunteers. The volunteer network is managed in part by the Nevada State Climate Office at the University of Nevada in the Geography Building in room 115. It's also managed by the National Weather Service, which takes some of the data and puts them online and makes them available. The instrumentation for these sites, the volunteer sites, is fairly simple. It includes precipitation, temperature, and sometimes evaporation data, though not always. Paper coverage is slowly being turned to digital coverage for 141 stations in the state. A station locator is available at the website listed here. But it's important to remember one thing about these data. It's a fairly simple data collection effort, and I'll focus on one in particular in Manhattan, Nevada. This is managed by a woman named Euphemia Parker, who has been recording data for average precipitation, daily maximum and minimum temperatures since 1983. In 1984, after her first year as a trial, she was designated as part of a climate station, or the Climate Station Network in the United States. And this is an example of what the record looks like that she produces. On the left-hand side, you can see the maximum and minimum temperatures, and this was for August of 2000. You can see the maximum and minimum temperatures that she recorded for August the 1st. And you can see on the right-hand side notes about the weather. They included the fact that it was cloudy and smoky on August 1st of 2000. As we progress down to the 15th, for example, we can begin to see that there's some rain that she recorded. On the 16th or 15th, she noted about 1/10 of an inch of rain, and she put a bar across the middle of the precipitation component of this chart to indicate that between 1 and 2, a storm hit. She notes on the right-hand side that it was cloudy and rainy on that day. And the following day, also cloudy and rainy, a different maximum and minimum temperature, but the rainstorm then occurred closer to nightfall between 6 and 7. While there's a lot of information that can be gained from this, generally when this information is taken over to websites, only the portion that relates to the total amount of rainfall is actually recorded. Let's contrast that with the remote automated weather stations that are managed by a multi-agency group that has weather stations situated in both California and Nevada and elsewhere, primarily to look for threats of fire. The remote automated weather station network is supported by the National Park Service, the U.S. Fish and Wildlife Service, the U.S. Forest Service, the Department of the Interior, the Association of State Foresters, the Bureau of Indian Affairs, and it began in the 1980s. It was led by the Bureau of Land Management, and currently there are about 2,200 remote automated weather stations in the United States. The primary focus is wildland fire management. You can get information about the RAWS system with direct access to data downloads from the water resources or from the Western Regional Climate Center that's operated by the Desert Research Institute. This shows a photograph of a RAWS site. And this is a RAWS site in Pancake, Nevada. It provides the following information: wind speed at 10-minute average, maximum wind speed on an hourly basis, precipitation reported in 0.01 inches for each hour, and this is because it uses a tipping bucket rain gauge that has a level of resolution of 1/100th of an inch. There's a solar panel. Most stations are operated on a battery that's recharged by a solar panel. It reports barometric pressure every hour, fuel moisture and temperature at some stations, not all, soil moisture at some stations, not all, wind direction, 10-minute average wind direction, air temperature and relative humidity, that includes the current air temperature and 10-minute average relative humidity, and Penman evapotranspiration, hourly estimates that are done each hour to estimate the evapotranspiration rate. The data are transmitted to the geostationary operational environmental satellite operated from Boise, Idaho, and the data are actually made available with about a 15-minute lag time. So the type of instruments that are part of the Volunteer Weather Data Collection Network in Nevada are primarily 8-inch rain gauges with some room for inference about storm intensity, though in general, storm intensity data are not provided when these data are reported in digital form. The Volunteer Weather Data Collection Network also collects data about maximum and minimum temperatures for a day. The data from the Volunteer Network are generally available through the Western Regional Climate Center's website at the Desert Research Institute. They're also available through the State Climatologist office at the University of Nevada in the Department of Geography. The primary purpose of the RAWS network is to actually collect data that are related to fire hazard and fire danger. Weather is a key component to the danger and the risk associated with fires, and so the RAWS network is set up and scattered about the state in a way that will give firefighters the potential to understand which way fires might go and how severe they might be, and what level of fuel and fuel combustibility is available at specific sites. The RAWS network relies on tipping bucket rain gauges, and as we saw in the previous video, one of the things about tipping bucket rain gauges is that unless they're heated, they're not very useful for snow measurement. And what this means then is that the RAWS network does not have the capacity then to report accurate precipitation data in the middle of winter.